My voice is clear. I hope you're getting okay. 1 second. Just chalo. New thing, new topic we're going to learn today. In fact, backbone of your mathematics, calculus, everything. What you will do, whatever you do throughout your mathematics section, calculus, inverse trigonometry, which you will learn. Anyways, so everything has a common thing which you will see, that is your trigonometry. So without this particular chapter, you won't be able to, if this is not clear, then definitely other chapters will have difficulties. Maybe it may happen that some of you already have the idea of this particular chapter. It may happen you must have given some test in your school. I know that some of you have the idea. Mostly if you're in class 12, then definitely you must be having some of the idea. In 12th, you learned what is the inverse trigonometry, but in 11th standard, you will learn trigonometry. But definitely, if you are in 12th, so definitely you have to learn inverse trigonometry also, which is the next chapter. Next means the next part of trigonometry actually. Anyways, so first I'll discuss the content. It is not slightly different. Everything is the same. The thing which you are doing in your school, something extra things you're going to sit for your Olympiads and all. So definitely something extra though you have to learn. Something extra means extra content from this particular trigonometry chapter you have to learn. Now what extra you need to learn, that is I'm going to discuss. From this particular section, more or less from this particular chapter, basically the subsections you have, from each of the subtopics, a lot of questions have been asked in a competitive exams. Throughout, you will see in our first lecture, we will complete. In this lecture, this is our first lecture of trigonometry. In the first lecture, we will discuss angles and its measurement. This is the syllabus actually. Let me write from the left hand side. This is our syllabus. I think this is the topmost part. Yeah. Angles and its measurement. The first thing which you will see is angles and its measurement. Okay. I'm telling you what is there. This entire block, I consider this to be trigonometry and plane geometry. Those are going to sit for Olympiads and ISI entrance. Definitely geometry is very important. Okay. Plane geometry I'm saying, not your coordinate geometry, plane geometry. Angles and its measurement. Second thing you will learn is trigonometric functions, domain, range and all. Trigonometric functions. Okay, which involves domain, range, questions based on that domain and range. Okay, difficult questions we are going to see under functions chapter also, because that is also parallelly what we are doing. We are also doing functions also. Functions is a big chapter. Trigonometric functions, then allied angle and compound angle. Allied angle and compound angles. Allied angles and compound angles. Fourth one is, I think, conditional identities. Conditional identities. And fifth one is trigonometric series. Trigonometric series. Now this trigonometric series is not there in your school syllabus. This particular thing is not there in your school syllabus. This one. This is a portion from which questions have been asked in JEE Advanced, but not so far not asked in ISI entrance. So Probably this can be one particular portion. I told that this year this may be possible, but this year also there was no questions based on trigonometric series. I'll tell you what is sine series and cosine series. Here this involves sine series and cosine series. Sine series and cosine series. Sine series and cosine series. This is not there in your school syllabus. You won't find this in your NCERT book basically. Also not there in JEE Mains if you are preparing for JEE Mains. Then sixth one, a lot of things are there. This is a very big chapter. Trigonometric series. Then last is maximum and minimum values. Maximum and minimum values of trigonometric identities. Trigonometric identities. This is the overall content syllabus. Trigonometric identities. Okay. Apart from this thing, various other things might be there also, which I'll keep on adding. Apart from this thing, I consider this to be the separate chapter actually. You may consider this to be separate chapter, but this falls under trigonometry only. Under trigonometry, this is the content of chapter number 1. This is chapter number 1. Chapter number 1, you will have these things, 6 subsections all total. And in chapter number 2, you will see what is trigonometric equations. Trigonometric equations and inequations. Trigonometric equations. And second part is trigonometric inequations. Inequalities is also there. Now, among these all topics actually, 6 or 8 topics are there all total. From this particular section, angles and its measurement, or let's say trigonometric function, allied angle, compounding, and conditional identities mainly, this is very important for ISI. Questions have been there, a lot of times questions have been there. Okay, more or less pattern of questions are very common actually. Patterns are very common. Okay. So based on this thing, from every portion questions have been asked from in your entrance exams, any entrance exam you can see. Okay, except the fifth one. This fifth one, that is trigonometric series questions have been not asked in your ISI. Okay, never it was asked. So next year maybe those who are going to sit for the entrance exam next year, this can be one probable topic. You can mark with a star. And from here also questions have been there. A lot of questions have been there. Trigonometric equations also, inequations also. Last I guess this year only, or if I'm not wrong, this year or the last year, trigonometric equation question were there. 1 or 2 questions were there in your ISI entrance also. Anyway, so this is the overall analysis. Chapter 3 will be geometry, which will proceed with geometry. Before this, you need to study geometry, you need to have a very clear-cut idea of trigonometry. Very clear-cut idea. And then chapter 3 will be geometry onwards basically, because we are going to use trigonometry in geometry. And then chapter 4 will be inverse trigonometry, which like if you are in 11th, then you need not do this time. But if you want to do, you may do. Otherwise, 12 people have to do this. 12 students have to do this. What is inverse trigonometric functions, for which we will discuss later. What is inverse trigonometry? Acha, let us start with this thing. Start with the first chapter, that is angle and measurement. Now here in this chapter, angle and measurement, first of all, the first thing is we'll study what is the angle. Now first of all of you know what is an angle. Angle is what? Angle is basically something which is made up of two rays, basically some sort of thing like this. This is an angle, what we call as. This is an angle, what we call as. This is a very basic definition of angle. Now, some sort of changes or difference in angles we are going to see over here. First of all, to create any angle, what we need? To create any angle, we need two things. One is the initial line and one is the terminal line. To create any angle, you will need two things. One is the initial line from which the angle initiates actually, and one more is the terminal line. This is the terminal line. We'll call this the terminal line. These two lines you will need in order to create an angle. Okay, I'll start with the very basics and then I'll keep on increasing the level as I do. So initial line and terminal line creates an angle, and here the angle is always considered in the anti-clockwise sense. If you ask the question why it is considered to be anti-clockwise sense and not clockwise, yes, it is also considered to be clockwise sense, but in general we consider the angle in the anti-clockwise sense. It is a standard convention. There is no certain proof for this. This has been already defined. So it is a standard convention we follow. That is, the angle is considered in the anti-clockwise sense. Okay, in this manner, the arrow which I am showing it to initial line to the terminal line. In the angle can be considered in this way also. The angle can be considered in this way also. This way also the angle can be considered in the clockwise sense. That is also accepted over here. In that case, this is your initial line. I have considered this to be the initial line. And this is the terminal line. Now, in case of anti-clockwise sense, when we consider the angle to be anti-clockwise sense, then the angle is considered to be the positive angle. Then the angle is considered to be positive angle in case if we consider in the anti-clockwise sense. And in case if we consider in the clockwise sense, then the angle is considered to be negative angle. Now here there is one more thing, angle. When we are saying angle, why this is, we are saying that why this is a negative angle. First of all, there is nothing, what is called as negative angle. Angle is not negative. The direction is negative actually. Okay. In detail meaning I'll say throughout my lectures, like over here. What is the in detail or in deep meaning of this thing? I'll say throughout your trigonometry course. But right now, this is the standard convention we follow. That is, positive angle is what we consider in the anti-clockwise sense, and the negative angle is the angle what we follow in the clockwise sense actually. Okay. In the clockwise direction, we have negative angle. Okay. Angle is not negative. The direction in which the angle is measured, that is actually negative. Direction is negative. So overall, what happened previously, mathematicians used to discover this thing by creating a unit circle. I'll just take a circle over here and I'll explain it to you. Previously, what happened, mathematician found this particular way of defining the angle, what we are going to discuss over here. Although trigonometry, so you have done in your 10th standard also. That is up to, you are very much clear with this particular degree measure, which you have done up to 10th standard. But right now we will focus on one more measure, a new measure, that is a radian measure. Up to 10th standard, you have done degree measure. Up to 90 degrees, you have done in your 10th standard. Post 10th standard, from your 11th standard, or you will be starting with the radian measure, and angles more than 90 degrees also we are going to verify. We are going to see over there. Anyways, so over here, what happened previously, mathematicians came up with this idea that suppose you consider this, a mathematician took this particular circle, okay, and from the center we just measure the radius. This is r, suppose this is also r. Okay, let's say radius r1, I'm taking radius r1. Okay, and then he also measured the arc length over here. He also measured the arc length over here, this particular arc length. Okay, let's say this is arc length L1, suppose. He further continued drawing circles. For the, if you take the radius of this particular outer circle, let's say radius of this circle is R2, suppose. Also, he measured this particular arc length, which is L2. Arc length means this particular arc length I'm saying. Okay. Likewise, he kept on drawing the circles. Likewise. Okay. Kept on measuring the radius R3 and the arc length, basically this particular arc length L3, suppose. Okay. So mathematicians came up with this idea. When they measured this particular ratio, That is this particular arc length, when they measure this particular arc length and this particular radius, the ratio, their ratio means L1 by R1. Then further, if they measure this particular ratio, L2 by R2, they found that all these ratios are the same. All these ratios are the same. They came up with this idea that all these ratios are the same. L1 by R1, L2 by R2, all these ratios, as you keep on creating this thing, L3 by R3. Okay. And they gave this name to be theta. This particular theta. What is theta? Theta is actually this angle which is subtended at the center of the circle this way. This is your theta. So they came up with this name that is theta. Okay. So in general, angle or plane angle basically was actually discovered. The definition of plane angle was given in this manner, that if suppose you consider a circle, okay, and this radius is r, suppose, with an arc length, this particular arc length is L. The mathematicians gave this particular definition of theta, this particular angle theta. What is theta? Theta is actually L by R. This arc length divided by this particular radius. Theta is actually L by R. And this theta, whatever is this theta is actually, L by R is theta. This theta will be in terms of radians always. This theta will be in terms of radians. Now, what is radians? I'll tell you what is the radians. Till now, you have learned the degree measure. I'll also explain what is the radian measure. So this particular theta was discovered in terms of length of the arc and the radius of the circle. Theta is actually L by R. This is the formula. This much very basic idea. You must have also done this in your junior classes also, but this is the overall brief explanation I am going to give you before we proceed with the actual part of trigonometry. So whatever is theta, whatever is theta means whatever is this angle basically will give you the result in radian measure. Okay. There are different measures of measuring a particular angle. But right now you have only two portions in your syllabus. One is the degree measure and second is the radian measure. Degree measure and the radian measure. Now degree measure, you all know degree measure. We have done degree measure in your you have done in your 10th standard. What is the degree measure basically? In degree measure, what happens? I'll show you. Before that, let me give you one idea of this thing. Let's say suppose this content, I am telling you about this particular thing. Theta will be in terms of radian. Suppose, for instance, I'll give you one example also just to explain this thing. Suppose you have a circle, radius, let's say radius consider 6 meters. And let's say arc length you consider a 3 meter, let's say, arc length. So what will be theta? Theta will be in this case L by R. Theta will be what is arc length? 3 meter by the radius will be 6 meter. Now this particular thing will be in terms of half. This is not half degrees. This will be in terms of half radians from now onwards. Now you have to visualize things in terms of radians. Now very rarely we will use degree measures. We'll use radian measures from now onwards. Mostly, in most of the cases. Hardly we will use degree measures. If mentioned, then degree measures. But if not mentioned, anything not mentioned about the angle or something, we consider that to be radian measures. We will consider that to be as radian measures. Okay. So certain things I have told you from here. Again, some special cases you may consider. Some special cases you may consider is this thing. Suppose suppose let's say you consider this special case. Someone can ask that what is the meaning of 1 radian? Okay. What is the meaning of 1 radian, or what is the visualization of 1 radian, or what is the speciality of 1 radian? How do we represent it actually? What happens is, if you consider this thing, if you consider this particular radius is, let's say, r, okay, theta is what? This particular theta can be obtained from this particular arc length, the ratio of the arc length and the radius actually, L by r. Now, I'm telling you this theta is 1 radian. This is 1 radian when? If L is equals to r, suppose, if the arc length and the radius is the same, arc length and the radius are the same, then only theta will be r by r, which is 1. This is the representation of 1 radian. Then only this is actually 1 radian. Then only we will consider this to be 1 radian. If theta is r by r, which is 1 radian, okay, this theta is 1 radian when? If L is equals to r, means if radius and arc length, if both of them are equal, then only theta is equals to 1 radians. Okay, this is the visual representation of your radian measure. Further you will see certain more things, but before which I will say you certain important points regarding angle. Okay, we'll come to this particular portion of this particular discussion once again. Let's come down to certain types of angles, what you will see throughout. Angle can be 0 degree as well. Definitely, angle can be 0 degree as well. Generally, if you consider the angle in this manner, let's say this is your initial line. Sorry, this is your initial line. Okay, this is your initial line, short form of initial line. I'll use this IL. And this is your terminal line, let's say. Over here itself, you have your terminal line. Okay. No rotation took place only. This is your initial line. On the same line, there lies the terminal line also. So over here, the angle is actually 0 degree. There is the angle is not rotated itself only. So obviously, in this case, the angle is 0 degree in this case. Angle is 0 degree. 0 degree or 0 radians, both are the same thing. 0 degree or 0 radians. Why both are the same also? I'll explain. Angles can be more than 90 degree also, which you will study over here in this chapter. Up to 90 degree, so you have studied in your school level, in your 10th level basically. In your 10th level, you have studied up to 90 degrees, but angles can be more than 90 also. If you consider this way, the angle in this is your initial line and this is your terminal line. So gradually this particular angle which we are considering anti-clockwise, this particular angle is obviously more than 90 degrees, isn't it? This particular angle is obviously more than 90 degrees. Angles can be more than 180 degrees also. If you consider the initial line, suppose, if you consider this to be the initial line and this to be the terminal line, let's say. This to be the terminal line, let's say. Okay, basically what you are doing, this particular initial line, you are actually rotating by this manner. Okay, and you are taking the terminal line over here. Likewise, you are rotating anti-clockwise sense and you are taking the terminal line over here. So obviously in this case, first of all, this much is actually 180 degree, and post 180 degree you are moving further. So obviously this angle is more than 180 degree. This way also the angle is possible. Angle is more than 180 degree also. Okay. Angles between two lines can be 360 degree also. Angles between two lines can be 360 degree also. Like over here, if you consider this particular initial line, and let's say this is your terminal line. Okay. What we are doing actually, we are taking the initial line, we are taking this particular initial line, rotating anti-clockwise, and we are completely bringing up to this side. So here, the angle rotation is a complete rotation which is of 360 degree. Now, first of all, you will say that just now we have said the same idea, same logic where I have told you angle is 0 degree. And then once again, I am saying this particular rotation, this is 360 degree. Yes, it is the same thing, the same idea. You will see further in your trigonometry chapter also, sine 0 and sine 360 degree has the same value, value basically. Sine 0, you will see further in trigonometry, sine 0 degree and sine 360 degree have the same idea. This also has a relation in detail, meaning I'll say you in further topics in trigonometry as we proceed. But this is the idea. Yes, this can be the same also. Like what is the angle is 0 degree, angle is 360 degree. They can be same also. So likewise, angle can be very large. Angle can be very large. Angle can approach to infinity also. Your theta angle can approach to infinity also. In this way, if we consider, it can be more than 360 also. It can be more than 360. Likewise, you consider this to be the initial line. Suppose if I consider this to be the initial line, okay, it considers initial line. You start rotating this initial line, okay, first rotation, and then once again we are proceeding. Like over here, I am taking the terminal line. Let's say over here, this is your terminal line. All complete rotation we are going 360 degree, then more than 360 also further we are going. This is more than 360 degree. Angle is more than 360 degree. More than 360 we have rotated it. Okay. So gradually angle can be very large. Angle can approach towards infinity also. And if the angle is rotated clockwise, if suppose it can be rotated clockwise also. It can be rotated clockwise also. Likewise over here I have told you angle can be rotated clockwise also. In that case angle will consider negative. Angle will be negative in that case. The measure will be in that case negative. It can be considered to be negative angle also. So in that case, in case of negative angle, basically angle can also approach to minus infinity also. So angle can be both plus infinity or minus infinity. Angle can be both plus infinity, can tend towards plus infinity, can tend towards minus infinity also. Okay. Angle can tend towards plus infinity and minus infinity as well. This is the overall idea of angles. Now, right now, what you will study? You will study two things. This is the common logic of angles. How is your situation of your angles and all? Right now, we are going to study the two measurements of angle. One is the degree measurement and the second one is the radian measurement. Okay. Degree measure and the radian measure. What is the difference? In case of degree measure, let's say. In case of degree measure, what happens? Here, degree measure, in degree measure, basically, logic is very simple. You have learned this in your 9th and standard also. Logic is very simple. In case of degree measure, we consider a circle. We divide this circle into 360 equal parts actually. 360 equal parts like this. Okay. And here means we have considered this circle like since this complete rotation is described as 360 degree. After taking this circle, we divide this into 360 equal parts, and each of these equal parts, each of these are known to be 1 degree. Each of these were known as 1 degree actually. Okay. Each of these were actually 1 degree. Each of these portions, each of these slices actually are known to be 1 degree. That's what we do in case of degree measure. Basically 1 degree is what? If a complete rotation is actually 360 degree. All of you know this. Complete rotation is 360 degree. So 1 degree is what? 1 degree is 1 by 360th of the complete rotation. 1 degree will be 1 by 360th of the complete rotation. 1 degree will be 1 by 360th of the complete rotation. Okay. So likewise, this is the very basic idea of regarding your degree measures. What happened is this particular thing, certain things were described. Like over here, we consider the circle. This circle were divided into 360 parts, and each of these parts were known to be 1 degree. Each of these parts were known to be 1 degree. Okay, basically 1 degree is about 1 degree is a very small angle. 1 degree is a very small angle like this. Okay, if I just enlarge this and show you 1 degree, each of these portions, each of these slices were considered to be 1 degree. Of course, 1 degree is a very small angle. Further, 1 degree was further divided into further more parts. This particular thing where divided into further portions. This was further divided like in this way. Very, very small parts. 1 degree was further divided. Okay. And this was divided into minutes. Each of these were known to be minutes. Basically 1 degree, we say 1 degree to be 60 minutes actually. Okay. Like just in this manner, if we divide 1 degree into 60 parts, we divide it into 60 parts. Okay. Each of these portions, likewise, very small portions. Each of these were further divided. If I divide this 1 degree into 60 parts, then one part will be known as 1 minute basically. One part will be known as 1 minute. I divide this angle into 60 parts and each of those parts were said to be 1 minute. Each of those parts were said to be known as 1 minute. So what is the relation actually what we are getting from here? In terms of degree measure, basically, in terms of degree measure, what we have done, in terms of degree measure, 1 degree is what? 1 degree is actually we consider to be 60 minutes. 1 degree is considered to be 60 minutes. And further, these were further divided into seconds, like 1 minute is actually 60 seconds. 1 minute is actually 60 seconds. These are some relations you need to know. 1 degree is 60 minutes and 1 minute is 60 seconds. Okay. 1 degree is 60 minutes. Like this is the standard way of denoting a minute actually. 60 minutes. And 1 minute is 60 seconds. Double dash stands for 60 seconds. Double dash stands for 60 seconds. So gradually I can say that in terms of degree and seconds, 1 degree will be 3600 seconds. 3600 seconds. If 1 degree is 60 minutes and 1 minute is 60 seconds. So gradually 1 degree will be what? 60 times 60, that is 3600. 3600 seconds actually. So these are some relations you need to know. Very basic relations I am saying. These are definitions and relations you need to know actually. This particular part is important. Okay. Up to this, any questions up to this? Is this part clear to all? Up to this, whatever I've said so far. Clear for all? Okay. So likewise over here, in terms of degree and radian measure, now come to this particular difference. In terms of degree measure, basically, mathematicians came up with 2 different measures of the angles. One is the degree measure and one is the radian measure. Now, in case of degree measure, let me tell you, in case of degree measure, we will consider, let's say this is your initial line. Let's say this is your initial line and this is your terminal line, let's say. Okay. And let's say you are measuring this particular angle. You know, this is also known as straight angle. This is also known as straight angle, total 180 degrees. Exactly 180 degrees. This is also known as straight angle. So in degree measure, we will say this to be 180 degree. But in radian measure, it is not 180 degrees actually. In radian measures, it is actually, we will consider this to be pi radians. This same thing, we will consider this to be a pi radians. Now come down to radian measure. Degree measure to we have done. It is a very common thing you are doing from your junior classes, degree measure. Now come down to radian measures. Radian measure is what? Radian is, the definition of radian says, radian is an angle subtended at the center of a circle. The one which I was telling you at the very beginning. Okay. Now come down to that same part once again. Radian is an angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Okay. Basically, this is our standard definition for 1 radian actually. A radian means 1 radian, suppose. What is a 1 radian? This 1 radian. I just now told you it's a special case of 1 radian. How 1 radian is obtained? 1 radian is obtained from this particular portion when this radius and this arc length are the same. R by R basically. Theta will be this. Theta will be what? theta will be r by r, then only you are getting 1 radian. That is the definition of 1 radian. So a radian or 1 radian is an angle subtended at the center of a circle by an arc whose length is equal to the radius of the circle. Basic NCERT language, nothing special or difficult over here. Okay, and this is the diagram which I've told you in the very beginning of the class itself, beginning of this session. Come down to this particular portions which I've explained over here. This is how we will find out the theta. Theta will be L by R. We know the arc length and we know the radius. We'll simply find from there itself. Okay, very simple idea. So gradually, we will now have to understand this particular things, like over here, whatever we are studying actually. We have to now convert the degrees and into radians basically, because nowadays from now onwards, trigonometry is fine, you're studying trigonometry, but we have to study mostly in terms of radian measures. And this is the standard way of writing a radian actually. 1 radian, 1 raised to c. And if nothing is mentioned, suppose nothing is mentioned means, suppose if this is mentioned, sine 60 is mentioned, nothing is mentioned, no degree, no c or nothing is mentioned, we consider by default this to be radian measure. By default, this is radian measure. Sine 60 radians. Okay, if nothing is mentioned, if it is degree, then it is degree will be mentioned. This degree will be mentioned, 60 degrees. Okay. And if nothing is mentioned, then clearly this is radian measure. So what I do over here, come down to the radian measure part basically. We're going to do the definition for radian and what is 1 radian in terms of degree also we have to see, and how to convert also we have to see. In degree, I told you the straight angle we consider this to be the, in case of straight angle, this is a 180 degree. This is your initial line. This is terminal line. Okay, we are rotating by 180 degree. This entire degree basically it is 180. And in case of radian measure, the same thing in case of terminal line. If this is the initial line, this is the terminal line. The same thing. This is actually known to be pi radians. This in terms of radian measures will be known to be pi radians. The standard way in terms of writing 180 degree will be pi radians. All of you must have certain things in your very junior classes that 360 is actually 360 degrees 2 pi. You must have heard this somewhere, 360 degrees 2 pi. Now what is this 2 pi actually? 2 pi radians. 360 degrees 2 pi. 2 pi is nothing but 2 pi radians. Okay. Anyways, so over here, certain things what you will learn. Radian is what? Radian is something which is the angle subtended at the center. So this theta, this is a special definition for 1 radian I'm saying. A radian is given. Na? So in general, understand what I will say in general in radian is what? Radian is the theta, that particular theta, angle theta. That theta will be in terms of radians from now onwards, which we will consider. And a radian is a constant angle, first of all. A radian is a constant angle. Now, what is the radian? 1 radian, first of all, this is 180 degree is actually pi radians. Standard relation, you must be remembering this thing. 180 degree is pi radians. Okay. 180 degree is pi radians. So simple unitary method, if 180 degree is pi radians, so gradually 1 degree will be what? Pi by 180 radians. Pi by 180 radians. 1 degree will be pi by 180 radians. Okay. And 1 radian will be what? Radian to degree, degree to radian. You must be knowing these relations. Simple. If you remember this thing, the next process is just simply unitary method. 1 degree is pi by 180 radians. So 1 radian will be what? 180 by pi. 180 by pi degrees. Isn't it? 1 radian will be 180 by pi degrees. Okay. So these 3 relations, you must be knowing these 3 relations actually. One is converting degree to radians and radian to degrees. How to convert also, that is also I'm going to show you with the help of an examples, few of the examples, you need to know how to convert from minutes, radians and all those things to degrees and all. Overall situation, degree, radian, these things, relations, you must be remembering. Otherwise, it is again, the logic is very simple. You only see from here some special cases. Suppose you consider some special cases here itself. If you consider this circle, suppose if I consider this particular angle, suppose this is the radius. Okay, standard angle I am considering. Okay, how much is this arc length? Can you tell me? If this the radius is r, suppose how much is this arc length? Can you tell me in terms of r? Because we need to find this theta, right? We need to find this theta. This is 1/4 of a circle. This is 1/4 of a circle. Can you tell me how much is this arc length? 1/4 of a circle. What is the arc length in that case in terms of r actually? What is the arc length? Means quarters, the circumference of that particular quarter. Circumference of that particular quarter, correct. Simple idea. Total circle, if you consider total circle, the circumference is what? Total circle circumference is 2 pi r. All of you know this formula. Total circle circumference is what? 2 pi r. So this is what? This is a quarter of a circle. Quarter of a circle. This is a quarter of a circle. So gradually quarter means what? 1/4. There are 4 quarters. There are 4 quarters. So gradually for 4 quarters, this so for only 1 quarter basically. So what you will have for this particular quarter, arc length will be 2 pi r divided by 4. 2 pi r divided by 4. Only for this quarter, arc length will be 2 pi r divided by 4. Isn't it? So gradually over here, this will be pi r by 2. So this arc length is pi r by 2. So that is why you are getting this thing. You are seeing from here, this particular angle, this theta will be what? Theta in this case will be pi r by 2 divided by r, arc length divided by the radius, pi r by 2 divided by r. So r and r gets cancelled out, which is pi by 2. See, this is 90 degree, which is pi by 2. In terms of, if this is pi by 2 means what? Pi is 180 degree. Basically, pi means pi radians. I told you theta is always considered in terms of radians. So if theta is pi by 2, pi radians means 180 degree, 180 degree by 2, which is 90 degree. Okay. And that is exactly what I have considered this particular angle. Theta is actually 90 degree or pi by 2 radians. In terms of radians, it is pi by 2. In terms of degree, it is 90 degree. Okay. So likewise, you must be having the idea of certain angles. So I hope this particular relation is clear. I keep this under this box, this particular thing you must be knowing. Otherwise, the others are for problem solving, basic problem solving, you need to know these informations. Okay. So otherwise, only these points are important. You need to remember these points. 180 degrees pi radians. And few more points regarding like the angles, situations, or this formula. Theta is basically L by R, arc length divided by the radius. That is how you obtain the angle, basically angle subtended at the center, which will be in terms of radian, which is the definition of radian. Angle subtended at the center. Okay. Which is obtained by the ratio L by R. This much you need to understand. So now, so gradually over here, you need to start visualizing angles in terms of theta. Start visualizing angles in terms of theta. In terms of radian measures, basically. Degree to radian measures. If 180 degrees pi radians, we need to start visualizing angles in terms of radian measures. Like 90 degrees up to 90, so you have done. 0 degrees, 0 radians. 0 degrees, 0 radians. 30 degrees, pi by 6 radians. Pi radians means 180 degree by 6, which is 30 degrees. Okay. 30 degrees is pi by 6. 45 degrees is pi by 4. Then 60 degrees is actually pi by 3. 90 degrees is pi by 2. All comes from this relation. 180 degrees actually pi radians. Okay. Simple idea. Start visualizing angles from this way. More than this also you have to like 360 degrees 2 pi. 360 degrees is 2 pi. Okay. 270 degrees. 270 degrees. What is 270 degrees? 3 pi by 2. 3 pi by 2. 3 times 180 divided by 2. Okay. So likewise, you will have to, at the very beginning, you will have the difficulty to visualize this thing. 180 degrees to pi, actually pi radians, 30 is pi by 6, 45 pi by 4, but with gradually with practice you will learn all these. Okay. After this class, only right now itself, this you must be remembering all these particular notations. Very, very important. Okay. And the relation between minutes and degree, I have told you that particular thing I have already told you. Now suppose if suppose questions might be asked to convert, suppose you are asked to how will you convert angles in degrees. Basically you need to convert from radians to degrees. How will you convert? We will simply use this particular relation. Question is, suppose if I ask you a question, okay, I keep this relation in front of you. Suppose if I ask you the question that you need to convert from radians to degrees, actually convert into degree measure. How will you convert from into degree measure? Means radians will be given and you are asked to convert into degree measure. For instance, if I consider the any angle, suppose what can I take, 11 by 16, let's say, not a normal angle. 11 by 16 radians is given. Angle measure is given 11 by 16 radians. You need to convert this into degree. What you will do? To convert this into degree, first of all, 1 radian is what? 1 radian is 180 by pi degree. So 11 by 16 radius will be 11 by 16 into 180 by pi, isn't it? If 1 radian is 180 by pi degree, so obviously 11 by 16 radians will be 11 by 16 times 180 by pi, which will give you the degree measure, this degree. Now if you simplify, whatever is your answer, okay, you can consider this pi. So this is actually 11 by 16 into 180 times 7 by 22. Okay, by pi is there, so 7 by 22 degrees actually. So that is basically simplify this thing, whatever you're getting. Okay, simplify and that is your result. So what we'll do, we are converting from radian to degree. So from converting from radian to degree, what we'll do, we will multiply by 180 by pi. To convert from radian to degree, what we'll do, we will multiply by 180 by pi. Now suppose if I tell you to convert into radians, now convert into radians, what you will do, you will multiply by pi by 180. If I ask you to convert 2 degrees, convert 2 degrees in terms of radians. So 2 degrees in terms of radians will be what? 2 times pi by 180. 2 times pi by 180. Understand from here itself. Let's take one question itself. This is a simple question. You can simplify. Now I'll show you. Suppose over here, if the question is asked in this manner, convert into radians. Convert into radians. Okay. This small questions can be asked. Convert into radians. For instance, suppose if I tell you, let's take the first question in itself. How questions will be given? If I take a simple degree measure, then it's fine. A simple degree measure, I'm taking a very simple degree measure question. When I convert 20 degree in terms of radians, a simple question. 20 degree in terms of radians, all of you can convert 20 degree in terms of radians. 20 times pi by 180 will give you the answer. To convert this into degree, from degree to radians, what you will do? 20 degree is what? 20 times pi by 180. You will get the radian measure. Answer in terms of radian measure. Question is in different manner. Suppose if I ask you convert into radians, suppose let's say any example, suppose I consider Basic example, suppose I'm considering, let's say 20 degrees and 30 minutes. Now see, 20 degrees is given and 30 minutes are given. Question is what? Convert into radians. How will you convert? See the process over here. This 20 degree and 30 minutes, I can write this 20 degree and 30 minutes as 20 degrees plus 30 minutes. Standard convention we follow, 20 degree plus 30 minutes. If this is in together in this manner, we can write it in 20 degree plus 30 minutes. Now we can convert individually. What we need to convert? We need to convert this into radians. Okay. First, let's convert this into degree all total, and then we'll multiply with pi by 180. Okay. So 30 degrees is 30 minutes are given. 30 minutes is what? 30 minutes is what? Half degrees. 30 minutes is what? Half degrees. What is I'll write down over here the relations, otherwise you will get confused. 1 degree is 60 minutes and 1 minute is 60 seconds. Okay. So 30 minutes in terms of degree. What I will do? Divide by 2 both sides. Half degree. This is half degree basically. So 20 plus half degree. Okay. So all total now this can be calculated. So that's how much? This is basically 41 by 2. 41 by 2. All total. 20 whole number 1 by 2. So that is 41 by 2 degree. Now convert this into radian measure. All total now this is in terms of degrees. If this is in terms of degree, now multiply with what? Multiply with pi by 180. Okay. Converting from degree to radians. Degree to radians. So 1 degree is pi by 180. So 41 by 2 degree will be what? Pi by 180 times 41 by 2. Plus that's all. Therefore 41 by 2 radians, degrees. In terms of radians will be what? To convert this in terms of radians, what we'll do? Pi by 180 times 41 by 2. Okay. In terms of radians, this will be 41 pi by 360. 41 pi by 360 in terms of radians. You may give this C or just simply leave out like that. It's the same thing. If nothing is mentioned, then we simply consider this to be in terms of radians. Okay. Now you all tell me, you all solve one question first. Solve one question, very basic one, and tell me in terms of radians. You all solve one question. Convert this minus 47 degrees, 30 minutes. Convert this first in terms of radians. Minus 37 degree, 47 degree and 30 minutes. Convert this into radians. Minus 47 degrees and 30 minutes. Tell me in terms of radians. Bolo, কি আসছে? What are you getting? Shorab minus 19 pi by 72. Correct. Minus 19 pi by 72. Minus 95 pi by 360. Simplify করলে তো তাই আসবে। অনিত simplify করলে তো তাই আসবে। Minus 95 আসছে। ঠিকই আসছে। Minus 95 by 360. Same. Minus 47 degree and 30 minutes. Simple idea. Again, the same thing. You can write it as minus 47. Take minus common. Write this as minus 47 plus 30 by 60 basically. 30 minutes is what? Half degree. Okay. So I'm writing directly half over here. The whole degree actually. Okay. So this is nothing but minus 47 whole number 1 by 2, which is minus 95 by 2. Minus 95 by 2 degrees. So what is this actually? So minus 95 by 2 degrees, convert this into radians. So minus 95 by 2 into pi by 180 into pi by 180. So this is, if you simplify this thing, you will get minus 19 pi by 72, the one which he has said, Shorab and Panith, which is minus 95 pi by 360. So if you simplify this thing, you will get minus 19 pi by 72 radians. In terms of radians, this is the answer. Okay. Now you'll solve one more question. Last question. Now solve this one. Last question. Convert this one. 5 degree, 37 minutes, and what to take? 30 seconds. Okay, 30 seconds. Double dash is not visible clearly. 30 seconds. Convert this fast. 5 degree, 37 minutes, 30 seconds. Convert this fast. Convert into radians. কত আসছে? $675 pi by 120 into 180. এই হবে, তুমি হয়তো সিম্পলিফাই করো না, যাই হোক যাই আসছে। Have the simplified answer. Simplified answer I am getting is pi by 32. Correct, pi by 32. Pi by 32. 5 degree, 37 minutes and 30 seconds. Yes, correct. Pi by 32 is the simplified modified answer basically. So 5 degree, again the same logic. 5 degree, write this as 5 degree plus 37 minutes plus 30 seconds. So 5 degree plus 37 minutes is basically what? Again convert this 37. Acha, first of all convert everything in terms of degree measure. 37 minutes, seconds and all these are given. 37 plus 30, this particular thing, 37 minutes plus 30 seconds, I can write this as 37 whole number 1 by 2 basically. So that is all total minutes. If I convert this into minutes, this will be this minutes, this number of minutes. Okay, 30 seconds, I am converting this into minutes in terms of minutes basically. 30 seconds, that's half minute. So clearly so this will be 37 whole number 1 by 2 minutes. Okay, so this is actually 5 degree plus 75 by 2 minutes. Now once again convert this into 75 by 2 minutes. Convert this into degrees. How will you convert? 5 degree plus 75 by 2 minutes into minutes you have into degree you have to consider. You have to convert into degrees. So 75 by 2 into 1 by 60. 75 by 2 into 1 by 60. Isn't it? 75 by 2 into 1 by 60. So 5 degree will be what? 5 degree plus this thing. Simplify this thing, whatever is the answer. You just simplify this thing. How much you're getting? 15, and this will go with 12. So this is actually 5 by 8. 5 by 8 degree. Okay, 5 by 8 degree. So 5 whole number 5 by 8, that is basically 45 by 8 degree. 45 by 8 degree. So now simply what? Convert this 45 by 8 in terms of radians. 45 by 8 into pi by 180. 45 by 8 into pi by 180, which is pi by 32 radians. pi by 32 radians. Okay, this radians. That's all with these type of questions. Chalo, let's see next. Okay, simple note. Just now we have seen to convert radians into degree, multiply with 180 by pi, and to convert degrees into radians, multiply by pi by 180. Simple note. Just now we have seen. Nothing new over here. Keeping under box. When you see the slides, you can see this. Okay. Chalo, next. Questions are there. Chalo, let's start with the questions. Some basic questions are there. Basic questions, and then we'll move on to advanced questions. Basic question first of all. In a circle of diameter 40 centimeter, the length of the chord is 20 centimeter. Achha. You have to find the length of the minor arc of the circle. Okay. You have two things. First of all, circle of diameter 40 centimeter is given and length of chord is 20 centimeter. Chord length is given to be 20 centimeter. So first of all, you need radius, right? What they are asking for, length of the minor arc. Arc length you have to find out. Arc length you have to find out. Also, theta is not given. Theta is also not given. First of all, if you consider this circle over here, what I'm trying to show you over here, this is a circle. Sorry. Just a second. Wait. This is theta, suppose. This angle we have to find out. We need actually. Okay. Arc length is also not given. Length of the minor arc, they are asking for the length of the minor arc. And the length of the chord is 20 centimeter. Length of the chord is 20 centimeter. What is the meaning? Length of the chord means, suppose over here, if I consider this, first of all, we can find a radius from here. What is the radius? Diameter is 40 centimeter. So gradually radius will be 20 centimeter. From this part, we can find out radius. Radius will be 20 centimeter. Diameter 40, radius will be 20. So gradually, if radius is 20, this particular radius, total diameter is 40, this radius is 20. Okay, radius is 20. This is 20 centimeter. And length of the chord is 20 centimeter. Also, length of chord is 20 centimeter. This particular length of chord, suppose if I draw a chord from here, this is the length of the chord is 20 centimeter. Gradually. So can I say this particular triangle is what? Equilateral triangle. Can I say this thing? This triangle is equilateral triangle, isn't it? Three sides are same. Chord is also same. This particular radius is also the same. So this is an equilateral triangle. Because this is an equilateral triangle, this angle, each of the angles will be 60 degrees. Isn't it? Theta will be 60 degrees. The angle which is subtended at the center will be 60 degrees. Okay. Next, what? You need to convert this into 60. Sorry, in terms of radians, basically. You need to convert this in terms of radians. Okay. You need to convert this in terms of radians. How will you convert in terms of radians? Simple logic. 60 degrees is given. So to convert this into radians, what I will do? Pi by 180. 60 into pi by 180. Basically, theta is actually 60 degrees. This angle. You can give this some name. Suppose if this is the center O, this is A and this is B. Chord AB is given. AB is our chord. Okay. Angle AOB is actually 60 degrees. It's a right angle, sorry, it's a equilateral triangle. Triangle AOB is equilateral. So gradually, therefore, what I can say from here, we need to convert this theta in terms of radians. So theta will be what? Theta in this case will be 60 times pi by 180 basically. Isn't it? pi by 180. 60 degrees is given, pi by 180, which is nothing but pi by 3. Directly you should remember this. See, 60 degrees given. I told you standard angle is there. 60 degrees means pi by 3 itself. Directly you should remember this thing directly. Directly you see this thing pi by 3 bus khatam. So theta is pi by 3 from here. Okay, this is what pi by 3 in terms of radians. I told you theta is always consider this to be radians. Okay, so theta is in terms of radians, which is in terms of pi by 3. Theta is pi by 3. So next what? We have got theta. We have got the radius now. So find out what is the arc length. Minor arc length they have asked to find out. What is arc length? Find out. What is arc length? Use the formula. Theta is what? Theta is actually L by R. Okay. So L they are asking for this L. What is this L? L is what? R times theta. Okay. So R is what? R is basically 20. And theta we have got this from here. Theta is actually pi by 3. Theta is this pi by 3 radians. Okay. So all total 20 pi by 3. Okay. 20 pi by 3 centimeter. Fine with this question. Any questions here in this question? 20 pi by 3 question. Very basic NCERT level question. 20 pi by 3. Any questions here? Is this question clear? Shall we proceed to the next one? If this is clear. Okay, good. Chalo. Next. Solve this. You yourself solve this. If in two circles arcs are the same length, subtend angles 60 degree and 75 degrees at the center, find the ratio of the radii. Find the ratio of the radii. Correct. Simple question. If you want to visualize this thing, basically this is given. These two things are given actually. Small circle and consider one more circle. Correct. 5:4 is the right answer. This, let's say this is 60 degree given. Subtend angle 60 degree. First of all, though, you need to convert. I'm telling you, if this is subtending an angle 60 degree, 75 degree, you need to convert in terms of radians. It may not, in this case, in this particular question, this will have no impact. Maybe it will have no impact. Maybe. Why? Because I'm saying that they are finding out the ratio. They're asking to find out the ratio. While finding the ratio, certain things will get cancelled out. It may happen that there is no impact on this. But anyways, standard process is to convert this in terms of radians. Okay. So let's say this is R1 and there is one more circle which is subtending angle is actually 75 degree. 75 degree. This is having radius R2. Okay. Arc length same. They have mentioned arc length is same. L1, L2. Arc length is same. I'm sorry. If this is L and this is also L. Arc length is the same. So gradually, if this is L, this is also L. Okay. We will use this relation basically for this one. For this one, basically, we will use this theta 1. Here, theta 1, we will use theta 1. Theta 1 is actually L by R1. And for this one, we will use theta 2, which is L by R2. Okay. The first task is to convert this particular 60 degree in terms of radian measure. So 60 degree in terms of radian measure will be 60 degree in terms of radian measure. Obviously, in this case, it is pi by 3. Just now we have seen it is pi by 3. 60 degree means pi by 3. And one more is 75 degrees. 75 degrees is what? 75 degree means 75 times pi by 180. How much? 15 with 15, this will go 5, and this is 12. So 5 pi by 12. 60 degrees pi by 3, 75 degrees 5 pi by 12. Okay. So theta 1, this is actually theta 1. Theta 1, so that is theta 1. Basically, you're getting this was theta 1, which is 60 degree, is pi by 3. So pi by 3 equals L by R1, and theta 2, which is 5 pi by 12 now. 5 pi by 12 is actually L by R2. So now compare and simply solve. You can simply divide, or we have L on both sides, so you can simply equate both of these L. From both of these equations, you're going to solve for what? You're going to find out what is R1 by R2. Simple. So L, you can equate both of these L's actually. Okay. This is actually pi by 3 times R1 is equals to 5 pi by 12 times R2. So pi cancels out from here. So this is actually R1 by R2 will be what? This is 5 by 4. So gradually R1 is to R2 will be 5 is to 4. That is their ratio of their radii. This question is also there in your NCERT also. NCERT questions all. Chalo, next one. You will try. The angles of a triangle are in AP. Acha, chalo. AP they have mentioned. First of all, understand some certain things regarding AP. The angles of a triangle are in AP. Means three angles. You have three angles in a triangle. Obviously, they are in AP. If they are in AP, if three numbers are in AP, we will consider the numbers in this way: A minus D, A and A plus D. Why we will consider in this way? Now, what is the meaning of AP? You learn this under sequence and series portion basically. AP means there exists a common difference between their numbers actually. That common difference is D, known to be D. See, there is a common difference between their numbers, right? If you just subtract this number, A minus D, the difference is D. A plus D minus A, difference is D. So that is the common difference is known to be D actually. Any number which is in AP, when two numbers are in AP, suppose if there is a common difference in between them, let's say in this manner, 2 is there, okay, 2, then for instance 2, then 6, then 10 and so on. Common difference is 4. This is an AP actually. Common difference is 4 actually. Okay, 10 minus 6 is 4, 6 minus 2 is 4. This is known to be an AP. AP means arithmetic progression. Arithmetic progression. Now see certain things regarding AP. Since I haven't taught you this thing, sequence and series. Regarding certain points in this sequence and series means regarding this AP I am saying. If three numbers are in AP, you will consider the numbers in this manner: A minus D, A plus D. Their common difference is D. Common difference, there is a common difference. That is D. D is the common difference in this case. Okay. So your question is, why will we consider in this way? Why can't we consider in this way? A plus D, A plus 2D. This way also the common difference is also D. First term, if suppose this is your first term, A is generally considered to be the first term. Here also the common difference is D. A plus D minus A is D. A plus 2D minus A plus D is also D. Common difference is D. Yes, you can consider in this manner also, but this is a in this manner if you consider, then there will be a difficulty. Why? If suppose it's in a question, Suppose you had to find out the value of A. If you consider in this manner, you will get certain cancellations. You will get certain cancellations. By chance, you need to add three numbers, A minus D plus A plus D. D cancels out, you will find out the value of A from there. So that is why in general we consider in this manner, A minus D, A and A plus D. We don't consider in this manner. You may consider in this manner also. Calculation will be lengthy. Okay. So that is why we consider in this manner A minus D, A plus D. This is what is known as AP. There is a common difference between the numbers. So now it's given that angles of the triangle are in AP and the number of degrees in the least to the number of radians in the greatest is 60:pi. Find the angles in degrees and radians. First, try out this question. I have told you how to consider. First, how will you consider the angles? A minus D, A and A plus D. And then it is mentioned the number of degrees in the least to the number of radians. See, number of degrees in the least degrees, and the number of greatest radians is actually 60:pi. Radius ratio is given actually. You have to find out the angles in degrees and radians. Chalo, find out, solve this. Take 4-5 minutes time. Big question. Solve this. Okay. Chalo, let us solve this. Achha, first of all, what are the things given part by part? I'm going to explain. I told you if the angles are in AP, obviously angles will be give you numbers only. Three numbers are in AP. So you will consider anything in AP. Three items are in AP. You will considering A minus D, A plus D. Standard way of considering basically. So you will consider this to be A minus D. Let the angles be A minus D, A and A plus D. In this way, we will consider the angles A minus D, A and A plus D. Okay. Then what? Number of degrees in the least to the number of radians in the greatest. What is the meaning of this thing? If you catch this thing, then half of the things are done. First of all, to find out the angles, you need the whatever in degree, radians, whatever. You need to find out A and D also. You need to find out A and D. A we can find out. Easily we can find out A. Why we can find out A? That's why I was saying take in this manner. A minus D, A and A plus D. Don't take in this manner. A plus D and A plus 2D. Why? Because you can find out A easily from here. See, if you add them up, simply add them up. We know that the sum of these are what angles, right? So sum of their angles is equal to 180 degrees. So this is 180 degrees. So D and D will cancel out. 3A is equals to 180 degrees. A will be 60 degrees from here. A will be 60. That's why I was saying take in this manner. Take the angles in this manner. This is all in terms of degrees. Okay. A minus D degrees, A degrees and A plus D degrees. Okay. All these in terms of degrees I have taken. A minus D degrees, A degrees, A plus D degrees. Okay. So I am easily getting A from here. This is one benefit of taking in this manner A minus D, A and A plus D. Then what I do? So basically what are the angles now? Angles are now in this manner 60 minus D degrees, 60 degrees and 60 plus D degrees. In this manner the angles are situated. So now our next target is to find out D. How will I find out the common difference from here? What are the given informations? Obviously this is given, this particular thing is given that number of degrees in the least to the number of radians in the greatest is 60:pi. What is the meaning of this thing? Number of degrees in the least means least angle is what? First of all, look at the least angle. This will be the least angle and this will be the largest angle. Isn't it? Least angle will be 60 minus D degrees. 60 minus D degrees. Largest angle will be what? Largest angle 60 plus D degrees in terms of degrees. Now what they have asked? The ratio is given, isn't it? The ratio is given. So degree is in the least, find degree is in the least to the number of radians in the greatest. So this is the greatest, convert this into radian. That particular ratio they are asking for. Convert this into radians. How will I convert this? 60 plus d times pi by 180 radians. Pi by 180 radians. 60 plus d times pi by 180 radians means over here, whatever it is, after some simplification we'll see. So this ratio we are asked to find out. This ratio, least angle is to largest angle in terms of radians. Least angle in terms of degree is to largest angle in terms of radians. This is what they are asked to find out. Okay. So by this condition, what is given? They are asked to find out. This is given. This ratio is given. This is to 60 plus d degrees into pi by 180 radians. This ratio is given to be 60 is to pi. No need to write this. This is overall things, radians and degree. Overall, this is what I need to find actually. 60 minus d is to 60 plus d times pi by 180. Is the language clear to all? What we have done? Those who haven't done this thing. Those who have done this thing is fine. Those who haven't done this thing. Is the language clear to all? What we are doing actually, 60 minus d is to 60 plus d times pi by 180. Okay. This is given to be 60 is to pi in the question. This is given to be 60 is to pi. Okay. So now this is just what? This is the ratio. Simply now solve this from the ratio. 60 minus d divided by 60 plus d times pi by 180. Okay. This is equals to 60 by pi. Now simplify this thing. Nothing else. You have to simplify. We can write this as 180 by pi. I write this as 180 by pi. I write it over here itself. Okay, 180 by pi is there. Pi by 180 is there, so I will reverse this and write it as 180 by pi. Okay, overall this pi and pi getting cancelled out here. This is getting cancelled with 3. So overall what we are getting? 3 times 60 minus d divided by 60 plus d. Right hand side is 1. So all total 60 plus d is actually 180 minus 3d. If you cross multiply. So what are I getting from here? So 4d is actually 120, d is actually 30. So d is actually 30. Common difference is 30. So d, now we have got d. So if this is d, we have got a 60 degrees. So what are the angles? Angles are what? 60 minus d, 60 degrees, and 60 plus d degrees. Basically, so the angles are, what are the angles finally? Angles are 60 minus 30 degrees, 60 degrees, and 60 plus 30 degrees. What are the angles? So total 30 degrees, 60 degrees, and 90 degrees. 30, 60, and 90 in terms of degree measure. Find angles in terms of degrees and radians. So in terms of degree, this is 30, 60, and 90. So to convert this into radian, what you will do? Simply multiply with each of them pi by 180. So in terms of radians, this is 30 times pi by 180, 60 times pi by 180, and ultimately 90 times pi by 180. So all total. Now simplify. This is how much? So this is pi by 6. Otherwise, these are simple angles. 30 by just I'm showing you the workings. How do we convert? 30, 60, 90s are standard angles you need to remember. Pi by 6. This is pi by 3. 60 degrees means pi by 3, and this is pi by 2. In terms of radians, in terms of degrees, and in terms of radians. Okay. Practice problems are not there with this particular thing, with this particular PDF. I'll give you the practice problem with this also. Okay.